This is Calculus 2. We're going to study Taylor polynomials. Previous sessions, we discussed about Taylor series, Maclaurin series. So we also learn how to find the Taylor Maclaurin series when you have functions. Now, our interest is how can I use Taylor series. Fundamental idea about Taylor polynomial is we're gonna approximate some value of function by using the Taylor polynomials. Let's get started Taylor polynomial. We study Taylor series of function. Here, right here, guys, you have the function f of x. We find the coefficient of power series by using the derivative. You plug in the center point in the derivative, then we find the coefficient. So that's the Taylor series. Taylor series have infinity sum. Here is extended Taylor series right here. That's extended form f of c plus f prime c 1 over 1 factorial x minus c right there. Guys, look at this series. We cannot find the infinity sum. So how gonna approximate the function of value? So we gonna trunk the Taylor series to approximate the function. So here's idea about Taylor polynomial. Taylor polynomial meaning is finite degree approximate of function. You take only finite term. How many terms we're gonna take depends on the error of approximation. Using the derivative and the specific point. How gonna use this one? Estimate complicated function. For example, e to the x, sine x, ln x with a simpler polynomial expression. You guys wonder when you use calculator to find, let's say, e to the 2, cosine 1.5, ln 2. How do you calculate to give the value of each functions? They're gonna use algorithm of Taylor polynomial. Let's get started Taylor polynomial. How gonna define Taylor Maclaurin polynomial, guys? I emphasize here polynomial. Polynomial have degrees, right? So here is the nth degree of Taylor polynomial. Center gonna be C, x equals C. So when you think about Taylor series, it's gonna be infinity series, infinity sum of power series. Now, Taylor polynomial is gonna be degree n from constant f of c, degree 1, degree 2, degree n. That's what we call nth degree Taylor polynomial. We can manage polynomial even though it takes a while to calculate polynomial, but we can manage it, we can find the sum of Taylor polynomial. But we cannot find the sum of Taylor series. Let's keep in mind. Center is 0. Special case is center is 0. The polynomial gonna be special name Maclaurin polynomial. So Maclaurin series, coming from Maclaurin series, T of n, same thing is degree n. So we gonna add the constant term, degree 1, degree 2, until degree n. That's we define nth degree Taylor polynomial, nth degree Maclaurin polynomial, right? So why use the Taylor polynomial? First one is much easier to compute than original function. I gave the example in the previous slides. How can find the value of function e to the 2, e to the 0 to 1, cosine 0.1, something like that. So if you want to know this value, we're going to use Taylor polynomial to find it. Second part is numerical approximation. Calculator use this algorithm, give the value of functions. Also, this one is a foundation for Taylor series and application in the calculus physics engineering in your future. Let's find the Maclaurin polynomial for f of x to the e to the x. There's a couple of different ways to find the Maclaurin polynomial for the function. So we can use Maclaurin series. Let's write down Maclaurin series for e to the x. So e to the x gonna be Maclaurin series summation n equals 0 to infinity 1 over m factorial xn. When you expand this power series, gonna be 1 plus x squared over 2 factorial plus 1 over 3 factorial x cubed 1 over m factorial xn. That's gonna be Maclaurin series for each of x. So we want to find, guys, T1. T1 meaning is degree 1 polynomial. So you're going to take the constant term until degree 1. So that's going to be 1 plus x. Let's go to T2, meaning is degree 2. So you're going to take from the constant to the degree 2. That's going to be 1 plus x plus 1 over 2 factorial x squared. Now T3 gonna be degree 3. So you're gonna take from degree constant term until degree 3. So that's gonna be 1 plus x squared to factorial plus x cubed over 3 factorial. That's all we call Maclaurin polynomial with degree 1, degree 2, degree 3. Now, question is, I'm asking you, which polynomial you want to use to approximate the e to the x function? Which polynomial give more close to e to the x value? Definitely this one, last one, because they have 4 terms. So this one have much close to the e to the x. But there is a trade-off. If you use more terms, you take more time, but you more close value to the e to the x. But t to the 1, less term, but that's easy to calculate to the e to the x value at the same time. Much bigger errors they give to you. So I'm gonna show the graph how approximate degree 1 polynomial, degree 2 polynomial, degree 3 polynomial to the e to the x. Look at this graph, guys. So I sketched the y equal e to the x graph. Now, let's sketch the T1, degree 1 polynomial. So pay attention here, guys. Pay attention here in the 0, very close x equals 0, because the polynomial expand x equals 0. Center is 0. Now, let's go to T2 polynomial. Look at the green one and blue one. Green one is much close e to the x function, right? Let's the degree 3 Taylor polynomial is much close to the e to the x. So degree is increasing and degree n is increasing. Taylor polynomial is getting close to the function e to the x. That's the idea. But there's a trade-off. So we want a highest degree of Taylor polynomial, and which is much close to the original function, but they have required time to calculate the value because they have a lot of terms there. So depends on errors, we're gonna pick the degree to approximate the original function. This time, let's practice Taylor polynomial for ln x. They give center here is, center is 1, not the 0, because ln x, domain of ln x gonna be, domain of ln x gonna be 0 and infinity. 0 is not included in the domain of ln x. So we cannot find the macro in series for the ln x. So that's why we have center is 1. So Taylor polynomial, we're gonna using definition of Taylor polynomial. So I'm gonna use general form of Taylor polynomial, nth degree. Tn is Tnx f of 1, center is 1, f prime 1 over 1 factorial x minus 1, second derivative 1, 2 factorial x minus 1 square, until when? F nth derivative 1 over n factorial x minus 1n. So T0 is degree 0, sorry. T1 is degree 1, T2 is degree 3, T3 is degree, T2 is degree 2, T3 is degree 3, T4 is degree 4. So look at this one. We need degree 4. So nth derivative, you need it. So I'm going to find nth derivative first. So let's find the nth derivative. Fx going to be ln x. F first derivative gonna be 1 over x. F second derivative gonna be negative 1 over x squared. Third derivative gonna be 2 over x cubed. Fourth derivative x gonna be negative 2 times 3, 6x fourth power. So find each of them. This one is f of 1 is ln 1. ln 1 is 0. F prime 1 is 1 over 1 is 1. F second derivative 1 is negative 1. F third derivative 1 is 2. F fourth derivative 1 is negative 6. That you find it right here. Now, let's find the T0. T0 meaning is you only have this term. So f of 1. So f of 1 is 0. That's 0. T1x, you need 2 terms until degree 1. F of 1 is 0. F prime 1 is 1. 1 over 1 factorial x minus 1. F second derivative x gonna be, you need until degree 2. So you only find f1 is 0, f prime 1. That's x minus 1. You add degree 2 term. F prime, second derivative 1 is negative. Negative 1 over 2 factorial. X minus 1 square. X minus 1. Negative 1 over 2. X minus 1 square. What is degree 3 polynomial? You need until degree 3 term. Which meaning is you add one more term. X minus 1. Minus 1 over 2x minus 1 square plus f third derivative is 2 over 3 factorial x minus 1 square. Let's simplify this one. X minus 1 minus 1 over 2 x minus 1 square plus 3 factorial meaning 3 times 2 times 1, 2 and 2 cancel out. This is 1 over 3 x minus 1 cubed. Let's do one more. Degree 4, add one more term. X minus 1 minus 1 over 2 x minus 1 square plus 1 over 3 x minus 1 cubed plus fourth derivative is negative 6. Negative 6 over 4 factorial x minus 1 fourth power. Let's simplify 4 factorial. 4 times 3 times 2 times 1. This one is cancel out. So you have x minus 1 minus 2 or minus 1 over 2x minus 1 square plus 1 over 3x minus 1 cube minus 1 over 4x minus 1 fourth power. So each time degrees increase, you add one more next term, find Taylor polynomial. Now, how gonna use this Taylor polynomial, guys? Look at this. T4 is degree 4 Taylor polynomial right here. So we wanna find T4. This is polynomial you can calculate very easily. So let's approximate T4. This is approximate. We're gonna say this approximate ln x, degree 4 polynomial. So let's find approximate value T4, 1 and 1. So how gonna calculate this one, guys? How gonna calculate this one? So you plug in the 1 and 1. Here is 1 and 1 minus 1, 0.1 minus 1 and 2, 1 over 2, 0.1 square, 1 over 3, 0.1 cube, minus 1 over 4, 0.1 fourth power. That you find it, right? So you're gonna use calculator for this. But I don't think a long time ago they don't have calculator for that, but you still use this to find it. This is 0.095308333. That's using the Taylor polynomial. Let's use the function ln 1.1. If you use calculator, you're gonna find this value gonna be 0.953101798. What do you think about this value here? Can you see the ln 1.1 is T4 1.1? This is Taylor polynomial. This ln function very close, right? Then what do you think this is different? Because ln function is Taylor series. That's what we're gonna represent. But we're gonna only take a degree 4, 1, 2, 3, 4 term. That's why they have different. But as you see, they are very close. So ln 1.1 approximate T4 1 and 1 Taylor polynomial with degree 4. So previous six, let's practice couple more. Previous one, we used definition of Taylor polynomial. This time also, we're gonna looking for Maclaurin polynomial cosine x. So let's using Maclaurin series to find the Maclaurin polynomial, guys, okay? So cosine x looks like, guys, here 1 minus 1 over 2 factorial x squared, 1 over 4 factorial x of 4, 1 over 6 factorial x 6 power, plus 1 over 8 factorial x 8, negative 1 and n minus 1, 2n factorial x 2n, okay? So that's gonna be, I wrong about power, guys. Here is n. So that's the Maclaurin series for the cosine x. So we want to find, the first one is T0. T0x gonna be, we talk about degree 0 Taylor polynomial, only constant term, that's 1. I say T2, guys, T2x, this is degree 2, so degree 2 is 2 terms right there. So this one is 1 minus 1 over 2 factorial x squared. T4x gonna be degree 4. You're gonna take constant 2 until degree 4, 1 minus 1 over 2 factorial x squared, 1 over 4 factorial x fourths. T6 is degree 6, which meaning is constant term until degree 6. That's gonna be 1 over 1 over 1, 2 factorial x squared, 1 over 4 factorial x fourths, minus 1 over 6 factorial x6. That's the degree 6 Maclaurin polynomial for cosine. B part is we're going to approximate cosine 1, okay? Before you find the cosine 1, let's use Taylor polynomial T6 1. That's going to be 1 minus 1 over 2 factorial plus 1 over 4 factorial minus 1 over 6 factorial. So if you use calculator, then you're going to see this value going to be, I'm using calculator, 0.540277778. Okay? How about cosine 1? Cosine 1 give, calculate the give 0.5403029. They're a little different right here, guys, because of we only take this degree 6 polynomial. So here is a little different, 23059. Here is 3023059. Here is 27778. But there are little difference errors right there, but very close cosine 1. So you're going to approximate cosine 1 with Taylor polynomial with the degree 6, okay? That's we use Maclaurin polynomial, okay? So sometimes you can use series to approximate Taylor polynomial or Maclaurin polynomial. But sometimes we don't know the Taylor Maclaurin series, so we have to use in definition. Let's do this one, guys, okay? So they say degree 3, so we have find T3. T3x gonna be degree 3, center is 1. So we have f of 1 plus f prime 1 over 1 factorial x minus 1, f second derivative 1 over 2 factorial x minus 1 square, f third derivative 1 over 3 factorial x minus 1 cube. So matching this number and degree, okay? Let's find the first derivative. F prime x gonna be 1.5, 1 over square root x. Guys, make sure this one, how gonna find it, guys? Another way, 1.5, x negative 1.5. F second derivative x, 1.5, negative 1.5, x negative 3 over 2. That's the second derivative. So this one is negative 1 over 4, x negative 3 over 2. Third derivative, x gonna be negative 1 over 4, negative 3 over 2, x negative 5 over 2. Now, let's find f over 1 is 1. F prime 1 is 1.5. F second derivative 1 is negative 1 over 4. F third derivative 1 is, here is what? Negative, negative, positive, 3 over 8. You find it? Now, let's find T3. T3x gonna be, f of 1 is 1, f prime 1.5, 1 plus 1.5, x minus 1, plus second derivative negative 1/4, negative 1/4, 2 factorial, x minus 1 square, plus 3 over 8, 3 factorial, x minus 1 cube. Now, simplify this one first. What is that one? Right here, guys, right here, negative 1 over 4 divided by 2 factorial, negative 1 and 4, 1.5, that's negative 1 over 8. Have to make sense? How about next one? This one. 3 over 8 over 3 factorial. 3 times 2 times 1, that's a 6. 3 over 8 times 1 over 6. Here is cancel out. 1, 2, 1 over 16. So you have now 1 plus 1.5 x minus 1 minus 1 over 8 x minus 1 square plus 1 over 16 x minus 1 cube. That's going to be polynomial degree 3 for the square root of x. Now, using this Taylor polynomial approximate square root 1 and 1. So this one is, you're going to say approximate square root of x. Okay? So let's approximate the value. So square root of x, square root 1 and 1, approximate t 1 and 1. So you plug in the 1 and 1 here. 1 plus 1.5, 0.1 minus 1 over 8, 0.1 square plus 1 over 16, 0.1 cube. So when you put this number in the calculator, we find 1.048875. The calculator using this algorithm to give the answer of square root 1 and 1. Guys, very clear how to use Taylor polynomial, Maclaurin polynomial for the given function. Let's do one more practice problem for Taylor polynomial. So I give the f of x, x e to the x, center is 1. So we're going to find degree 1, 2, 3, okay? So here is write down Tn. Here is f of 1, f prime 1 over 1, x minus 1, f second derivative 1 over 2 factorial, x minus 1 square, f third derivative 1, 3 factorial x minus 1 cube, until f nth derivative 1 over nth factorial x minus 1 n. So we need degree 3, degree 1, degree 2, degree 3. So let's find the derivative f of x, x e to the x. F first derivative, we're going to using product rule. Derivative x is 1, e to the x plus x derivative e to the x, e to the x. So this one is e to the x, 1 plus x. Second derivative x, derivative e to the x, e to the x, 1 plus x, plus e to the x derivative. 1 plus x is 1. The common factor e to the x, 1 plus x plus 1, e to the x, 2 plus x. Let's do third derivative x, derivative e to the x, e to the x, 2 plus x, plus e to the x, derivative e, 2 plus x is 1, e to the x, 2 plus x plus 1, e to the x, 3 plus x. I hope you see the pattern. So let's find f of 1, e to the 1. F prime 1 is 2 e to the 1. F second derivative 1 is 3t to the 1. F third derivative 1 is 4e to the 1. Guys, see the pattern? Now, let's find the degree 1 polynomial, degree 2, degree 3 right here, guys. T1x. You only take f of 1, f prime 1, x minus 1. F of 1 is e, plus f prime 1 is 2e, x minus 1. Degree 2 polynomial is until you're going to take until degree 2 right here. Here is e, 2ex minus 1. Second derivative is 3e1, right? Guys, here 3e 2 factorial x minus 1 square. Let's go T3. T3 gonna be, you're gonna add one more term. Right here, you find the e plus 2ex minus 1 plus 2 factorial is 2. 3e 2x minus 1 square. One more term. Third derivative, 4e over 3 factorial x minus 1 cube. What is 3 factorial? 3 factorial is 6. That's gonna be 6. That's you're gonna find the Taylor polynomial T1, T2, T3 for given function. I hope you understand Taylor polynomial, Taylor series. How gonna use Taylor polynomial